Okay. So in the last lecture, we had seen what is the difference between the thread and process. So the thread is nothing but it is a detachable unit of executions. In the today's session, we are going to see the life cycle of a thread, how the thread is getting executed, how the thread is created, and how that is running and how that is getting terminated. So that we will see in a life cycle. So if you are carefully seeing this diagram itself, it is just explaining that whenever the new thread is created, it means that whenever we are creating the object of thread, let us say thread T is equal to new thread. When I am creating that, T is nothing but the object. Okay, so that object is, whenever we are creating, that is in new state, newly born state. Okay, whenever we are giving the start method, at that time it is on the verge of entering into the runnable, it is into runnable state. So runnable state is nothing but it is on the verge of running the code, on the verge of running the particular program or the process. Okay, but not actually running. If you are giving the run method, automatically that is entering into the running phase. Okay, so whenever it is entering into the running phase, then at that time, after completion of running, it is automatically completing its executions and it is entering into the day. And if it is not, it is entering into the waiting state, either with the help of the wait or the sleep method. And the previously the suspend method, if you are considering the previous versions of Java, then at that time suspend is the method to enter from running into the waiting phase of a thread. So what is happening if I am giving the wait, unless and until we get the notify, that is not entering into the running state. Okay, if it get the notify, then automatically from the waiting state, our thread is going into the running state. Similarly, the slip is provided with the millisecond. Let us say that the slip 1000 is written within this bracket, then at that time, after 1000 millisecond, automatically the program will be entering into the running state. Okay, and after completion of all the processing, it is entering into the dead state. Okay, this is nothing but this is just explained here. A new thread begin its life cycle in the new state. It remains in this state until the program starts the thread. It is also referred as a born thread. Runnable. After a newly born thread is started, the thread become runnable. Okay, after a newly born thread, it means that whenever we have created the thread, after that the next step is nothing but the runnable. It is nothing but the stage which is on the verge of running but not actually running. Okay, a thread in this state is considered to be executing its task. Okay, so waiting, sometimes a thread transition to the waiting state while the thread waits for another thread to perform a task. A thread transition back to the runnable state only when another thread signals the waiting thread to continue executing. It means that the thread is entering into the waiting state when another thread is trying to execute this particular program or particular process. Okay, is trying to execute a particular program. Then at that time, it will be waiting for some time, and after completion of that, it is again entering into the running state. Okay, timed waiting is nothing but the sleep, जैसे कि, and the wait is nothing but it is waiting till the execution is completed. Okay, here waiting for particular milliseconds. Okay, and at the last, the terminated or the dead state. A runnable thread enter the terminated state when it completes its task or otherwise it is terminated. Okay, so thread, now we will see the priorities of the thread. Okay, every Java thread has the priority that helps the operating system determine the order in which the threads are scheduled. So every thread of Java is provided with some priorities. The highest priority threads are always getting executed faster as compared to lowest priorities. The Java thread priorities are in the range between minimum priority and maximum priority. Okay, so 1 to 10. By default, every thread is given priority normal priority. So by default, the priority is given as the normal priority. It means that any thread it can execute this particular program. Threads with higher priority are more important to program and should be allocated processor time before lower priority threads. However, thread priorities cannot guarantee the order in which thread executes and very much platform dependent. Okay, so priorities does not guarantees the order in which thread executes and very much platform dependent. So they are platform dependent. So on the basis of platform, the priorities are getting changed. Okay, if you are using the Linux, the priorities may be different. If you are using the Windows, the priorities may be different. Okay, so I think this much is sufficient for the today's session. Next, we will continue afterwards.